Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. Today we'll see how to create parametric curtain panel system by recreating this very nice facade here entirely in Revit. As you can see, it has a very smooth transition from closed to open panels. Even better, you can fully control and edit the system if you really want to, because these are simply curtain panels with fully editable parameters. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single day. Alright, let's get started. Simply go to File, New, Family. And we can start from this template, curtain wall panel pattern based. In here, the first thing to specify is obviously the pattern type. Just select this grid there and change this to rhomboid. Then I can go to the top view and change those grid dimensions to resemble what I have here in the reference project. Let's go for 750mm horizontal spacing and 500mm for vertical spacing. Next step, I can now hide this grid just for now. If you look at the reference image, this will be one of our panels. And then that module will be repeated as many times as needed by the masking system. Let's go ahead and make this now. Firstly, we need to drop in here 4 more points. Let's go to reference point on a work plane and then set the work plane to be firstly here. I can then drop this new point right on top of this point number 1. We can do the same now 3 more times. When that's done, I can now select all those points, go to filter, and select only my reference points. Under properties now, you have this offset parameter. We can now put this as maybe -75. And that will bring those points down. Let's now link this into a parameter as well. I will call this one panel offset and make it a type parameter. We can now connect those new points in pairs. So let's get this point and then the opposite over here. Go to spline through points, click that, and this line will be created. I can now turn this into a reference line. Let's do the same now for the second pair. We now need to drop in here 4 more points. So the same thing again, reference point, but this time instead of placing new points on work planes, I will place them on face. And just drop them here and there. Next step, let's get this one for example. And I can see now the normalized curve parameter is 0.7. That means that along this line here, a point of parameter 1 will be somewhere there, and a point of parameter 0 will be here on the opposite endpoint. For today's lesson, we want to control the opening size of each curtain panel using this same parameter here. And to make that happen, you need to have all these 4 points in the middle having the same normalized curve parameter. At the moment, this one here has that parameter at 0.31, and this one is different at 0.75. To make them use the same value, I need to now change this point to have this curve parameter measured from the end of this line. And now that's more similar to what the parameter of the opposite point is. Let's do the same for the other pair. Let's check on this first one there. That seems relatively correct, around the 0.2, 0.3 range. That's what I need. But if I go and select the opposite point now, I can see I also need to change this to be measured from the endpoint of this second line. Now that I have them measured in the same way, I can now select all 4 points in the middle and put in here a sample value of maybe 0.25. And to control this easier in the project, let's now give this a link to this new parameter as well. Let's call this one param1 for parameter 1. And because I want each panel to have a different opening size if they need to, I need to create this parameter now as an instance parameter. You now might want to test it out. Just go to family types and watch here. If I change this to maybe a bigger value, 0.35, all 4 points should move in the same way. And they do. Let's now start creating the frame for our panel's geometry. We can focus on one endpoint at a time. So let's go for this one here and point number 1 and start creating a few lines. The first one between those 2 points. and the second one between that one and this one over here. We can now do the same 4 more times. Alright, let's now turn all those black lines into reference lines. Very nice. We can now use the same technique and connect 4 more point pairs. So those 2 is 1 pair, reference line as well, and let's do it 4 more times. Let's now start creating geometry between them. Using this method, I will select the first triangle there. Make sure to get this vertical line as well. You may have to control click to get it. And get those lines over here as well. Now, with 6 lines selected, I can now go up to here and do create form. And that gives me the first leg of our panel. Let's do the same now 3 more times. Amazing. I can now select all 4 form items and give them a material parameter as well. Let's call this simply panel. And while I'm here, why not go to family types and give this a white color. Simply duplicate that, go to appearance, duplicate the material asset, and choose the color white. Here we go. Nothing seems to happen, but if I go to shade it now, that color remains to be white. One last thing to do in this curtain panel family is this. Just go to family category and tick this box here that says cut with voids when loaded. You will see why in a minute, but we need this to freely manipulate this panel's geometry in the project later on. Press OK, and I can now save it with a good name. Panel 3 for now. We can now test it out in the mass family. Let's go to File, New, Conceptual Mass, and start from this template there, Metric Mass. In here I can start drawing the footprint of the reference project. We will try to create roughly the same geometry there. So let's go to Model Line, draw them on a work plane, and I can now set the work plane to be this level 1 plane. I can now start drawing from here. So something like that. We can now go here, select the set of lines, and do create form. Let's give this a height of 10 meters. I can now select those 3 front faces and divide them using this button here. We can now change the pattern to be rhomboid. And let's set the U and V grid dimensions to be roughly the same values we have in the curtain panel family. So this will be maximum spacing of 500. And for the V grid, maximum spacing of 750. Here we go. I can now go into the curtain panel family and load this into the mass family, family 2. We can now get those faces again. Go to here and change them to use panel number 3. Here they are. That does something nice, but not very clean if you look closely. You have many panels along the perimeters extending beyond the limit of their host faces. This is actually a Revit bug, and if you look it up online, there are different articles like this one here that gives more details about this bug. Essentially, if you have a divided surface and you use pattern-based curtain panels on them, the perimeter ones can just extend themselves by 2 inches or even more. There are different workarounds to resolve this problem. One of them is this. I can go back to the curtain panel family now. Go to the top view. And make it so that I can turn on or off each of these 4 sections as required in the project. Let's do it now. I can now select the first section there. Go to Properties under Visible. We can now control this tick box for visibility of this section by assigning a new parameter to this. I will just call this one top left and make it an instance parameter, because remember, we want to control this individually for each panel in the project. Let's do the same now 3 more times. Here we go. If you now go to family types, you can see that I've made bottom left, bottom right, top left, and top right. We can now load this back into the massing environment. Family 2 is there. Overwrite everything now. And let's say I want to select this panel here. I can then freely go to properties and untick the boxes for the top sections of this panel. And that will clean it up. Of course, I can do it for more than one panel at a time. So if I select maybe the top 3 ones there, and then do the same method, all of them will be cleaned up in one go. So let me go ahead now and do that for the rest of those perimeter panels. Okay, that's done now for the whole system. As you can see, it was a bit manual, which is why some people prefer to do this kind of geometry in other programs like Grasshopper or Rhino. These are obviously a lot more powerful, but then they will have problems with translating that geometry back into Revit. In here, we have everything ready and of the same correct category, curtain panels, so at least for now, this is an acceptable compromise. Okay, I can now select the whole system there, and then simply change this parameter value to make them all closed. You can go for 0.5, but that would generate an error, because if I go back to the family now, even in here, if I change this to 0.5, that won't do it, because here that means this point, and this one will be at the same place. That will mean that these 4 internal lines are reduced into a single point, which will generate an error. So, to get the panel to the closed position, we should go for something less extreme. That means instead of 0.5, we can try maybe 0.49. And that gives roughly the same effect. Alright, so far so good. But if you look back at the reference image, essentially we have only been able to recreate this part here, or at most a bit over here, because these are the only closed panels in the system. What about those? For those, you can either open up each panel individually or use Dynamo to do it quickly. Now, if you are new to Dynamo, don't panic, because this script is super easy and straightforward to create. And even if you have problems creating it, I will include a link in the description to download it anyway. Okay, let's open Dynamo now from the Manage tab. We can now go here to create a new graph. The first step now is to quickly select all those panels in the mass environment. You can now right click on this canvas and do a search for family types. In here, the drop down menu, you can expand it and then simply select the curtain panel family, panel 3. We can now right click one more time and type in here elements of family types. This one here. Connect this to that. And if I now expand this output, I have in here already selected 534 panels, which are all the panels I have right there. Now, to know which value to give to that parameter of each panel to control its opening ratio, I will need to put in here some attractor shapes, because then I can tell Dynamo to calculate the distance from each panel to that attractor. If the distance is low, give that panel a big opening. Otherwise, if the distance is high, then give that panel a narrower or smaller opening, or even close it completely. Let's create those attractor shapes now. I can minimize Dynamo for now. Go to the plan view. And let's draw in here 2 new additional reference lines. Just slightly offset versions of the ones already there. I will call this one plane number 1, and this plane will be plane number 2. Switch back to the south elevation now. I can now set plane 1 to be the active work plane and start drawing some ellipses. Maybe this one here. Make sure you have it drawn on work plane for now. I can now start drawing the first ellipse, maybe like this. And then a slightly bigger one here. If I now go back to 3D and reset the view, you will see them floating there as well. We can now draw one more ellipse on this other side. Just go to the east elevation now, set the work plane to be plane number 2, go to ellipse again, and start drawing from here. Just like that. Go to 3D now, and you can see my 3 new ellipses. We need to now give them to Dynamo, and the way to do it is this. Open up Dynamo one more time, right click, and search for select model elements. Make sure to get the plural version of these two. I can now select my 3 ellipses, isolate them in this view, click on select there, and do a window selection to get them all. Next step, I can now right click and search for elements.geometry. Connect this to that, and this will give you 3 ellipses. If I now activate the background view of Dynamo and do a zoom to fit, you can see them here as well. Go back to the graph view now. I need to now find a way to calculate the distance between each panel to those ellipses. To make that more accurate, I will firstly convert these ellipses into surfaces. And to do that, I will do a surface by patch node. Right click and search for by patch. If I now connect these ellipses to there, it will give me now 3 surfaces, as you can see there. We can now flatten the list. Just search for flatten. Connect to there. And now you can see those 3 surfaces are now on the same list. I can now join them using poly surface by joint surfaces. This one here. Connect this to there. And you can see now I have one single poly surface. Poly means many. That means this surface represents all 3 ellipses at the same time. Next step, I need to obtain the location point of my curtain panels. To do so, I need to put in here element.getLocation. Connect that to here, and you can see straight away in the background, we have now 1 point per curtain panel. And now we can now use them to calculate the distance between the points and the ellipses. For that, I will need an additional node, which is geometry.distance2. So, the geometry we want to be based from will be the points. I will now connect that to here then. And other means the other geometry that you want to calculate distances to. In this case, that will be my poly surface down here. And now if I expand this, we have straight away a list of distances. If you compare this list and that one, this one has 534 panels, and this other one here has 534 distances. So 1 distance per panel, exactly what we need. There's only one problem. These distances, they are in millimeters. So you can see the first one there is about 2.5 meters. This one here is about 5 meters. This one 6.5 meters, and so on. However, for our curtain panel, if I now select one of them, we need this value here for the parameter number 1 to be somewhere between just over 0 and just below 0.5. To convert these values to that new range, I need to use another node now, and we can do a search for remap. It's this one here, remap range. I cannot connect distances from here to this numbers input, and then specify a new min and a new max for this number range. To supply these 2 numbers, just right click on the canvas again and search for number. I can now copy this, Ctrl C and then Ctrl V again to get 2 numbers. This one can now be 0.01 and this will be 0.495. So just above 0 and just below 0.5, because our curtain panels would not accept 0 and 0.5. I can now have this as my new min, and this other one as my new max. Expand the input now, and you can see straight away. If I go back to the top, 2 meters and a half has been reduced to 0.08. 3 meters and 200 is now 0.1, and so on. Essentially, the minimum value here has been mapped to 0.01, and the maximum value here has been mapped to 0.495. I can now try to assign these values to the parameter 1 parameter of those curtain panels. To do this, usually people use this note here, set parameter by name. Here you have 3 inputs to specify. The first one is the new values. Just go and connect this one to there. The parameter name will be a text. I can now right click there and choose string. String means text in Dynamo. In here I can type in the parameter name, which is param1. Get it to there. And then finally I need to specify the curtain panels as my element input. They are still here. I can now connect that to this. If I now save the script and press run, it gives an error. This is usually a big problem with Dynamo because sometimes using nodes is a good way to get your logic up and running quickly. But also these nodes, they make certain assumptions. And in here, in this case, when the assumption is wrong, the node won't run. Anyway, no need to worry because I have exactly what can be the replacement of this node. Just right click here now and search for Python. Python is just a way of manually creating nodes. If I now double click on this, it gives me an editor to put in my Python node. I have one for this purpose copied into my clipboard already, so I can now select everything there, delete, and do Ctrl V to paste my custom node in. Again, no need to know all of these, because you will have a link to download this script anyway from the video description. For now, make sure it's in there, and I can now do save changes. For this Python script to run, I need to have 2 more additional inputs, so let's do the plus sign there twice. And now we can simply transfer these inputs from this erroneous node to this new Python one. So element, go to there instead. Parameter name, go to input 1, and then new parameter values will be in input 2. I can now select this node here and delete it. If I now click on run again, let's see what happens. Here we go. Now the result is what we expected, because here you can see, if I now just make Dynamo a bit smaller. Those panels, they are very far away from our attractor of ellipses. That's why they have now smaller openings. Those that are closer to the ellipses, they are now having large openings, but maybe too large for our liking, because if I now look back into the reference image, the degree of change seems to be a bit less. To get the same effect there, we need to tweak our Dynamo script slightly. It all has to do with this remap range node. As you can see there, those values becomes values between 0.01 and 0.49. To recreate the reference image more precisely, I need to make those numbers become 0.495 even before they should. That means my curtain panel should start closing earlier. The trick to this is to change this number now to something like 2. If I now disconnect this for a moment so it won't try to change our panel on the fly and run this, you can see these are now bigger values. I used to have 0.01 there, but now it's 0.3. Next step, we can now use these to change our panels, but not straight away, because remember our panel cannot accept values for that parameter that are bigger than 0.495. That means if I want to use these values now, I need to convert anything bigger than 0.495 to just 0.495. To do so, let's put in here an if node. And here you need to specify 3 things. The test, what will happen if the test is true, and what will happen if the test is false. I can now define this test by simply double clicking on this canvas. That will give you a code block where I can now put in here value is greater than 0.495. I want to test this condition now on all of those values. So let's connect these values now to this input. When I run this, you will see under here, it will come back as trues and falses. So this one, not greater than 0.4, that's a false there. But if I scroll down, I will have some trues. For example, this one here at number 156, if I now go to number 156 here, that is certainly bigger than 0.49. Alright, so the test is working. I can now connect this to the test value. Next step, we need to define what will happen if the test returns true. If this is true, that means this value is bigger than the maximum value the panel will accept. In that case, we need to give it the maximum value that the panel can use, and that will be 0.495. We can now right click one more time here, add in another number input, and simply use 495 here, and connect this to true. On the other hand, if the test returns false, we can just simply use the existing values. So to do that, I will just connect this list of values to the false input. Run this again, and if I now check on this value list here, and make sure I have my list in the same order, you can see this one is false, that's why this value is now retained there. And same for 1, 2, 3. But as soon as the value here is true, this cutoff value will be used instead. And that's why you have here 0.495 instead of this bigger parameter value there. Let's now try to connect these new values to this input port of our Python script, and then click on Run. Alright, something nice has happened. If I now minimize Dynamo now, you can see straight away it's working just like we expected. So the panels start closing much earlier, and that's how you see this nice transition from solid to open. Anyway, there's one last thing to sort out, and that is to do with those panels at this corner point. If you look closely to here, you can see that they don't really clean up nicely where they joined, because for obvious reasons, this panel here, for example, it belongs to the surface on the right, and that's why it has no knowledge of this surface on the left. It doesn't know that there's a panel here coming at it at 90-degree angle, so it fails to clean up. No need to worry, we can do this later in the project. Let's bring this into there now. I will save this family first. Massing 2, and then create a new project. Just use any template for now. In here there's nothing, but if I go back to my mass family now, I can just load this into my project. Project number 2. So when it's loaded and showing up, we can now just click here to place it. Here it is. If I now go to 3D, seems a bit messy, but as soon as I go up here and turn off massing, you will see that only those panels will remain. Anyway, you know what, while I'm here, I can see that from this panel to this one here, the transition isn't that smooth. It gets smaller too quickly. To fix this, I need to go back to my massing family now, open back the Dynamo script, and I can see the problem now. This should be 0.01, it should be something bigger. So I'll take out 10 there, and rerun the definition. Here we go. As you can see, once the definition is ready in Dynamo, it's super easy to update the numbers to get new options in your design. For now, I'm happy with this. Let me load this back into my project. That's also how you update a mass design. There are some steps, but quite straightforward. Okay, so now as promised, I will show you how to clean up this problem. The trick here is to create 2 more masses to serve as cutting elements. Let me show you what that means. If I now go to level 1 again, we need to now go up here and do an in-place mass. Let's call this one cutting object 1. In here, we simply need a triangle. I will draw it straight from here where the 2 panels intersect. Make sure it's trimmed and closed. Go to 3D now. I can now just create form from this, and make sure the form is high enough to go through all those panels. Maybe even extend it down a bit slightly. And finish the mass I will. Next step, we need to now focus on one panel to see how it works. I will now use this new mass to cut away the unnecessary portion of this panel right there. The trick is this: go to Modify, use a cut tool, click on the panel, and then click on the mass. You can see straight away that is now cleaned up. If I isolate it now, everything is nicely cleaned, even at that complex junction. We can now reset the view, and you are now free to do the same for the rest of panels. So if I do it one more time, cut, select the panels I want to remove some section off, and then select the cutting mask. You may ask, what will happen to this other side? How can I cut these panels on this other side? It's simple, just select this cutting object here and mirror it to make a copy. I can now select this face here for the mirror edge. And now, if I want to cut this panel for example, I can use the same method, but this time using this other mask as a cutting object. So just do cut, select the panel, and click on this second mask. The same happens there, and if I've done that on both sides, when I isolate these two for example, they will join very nicely. So feel free to do the same for the rest of panels on this edge. I have done so already, so I won't bore you with the details and go straight to this result. If I now go to 3D now, you can see that's what I did to join all of those panels here along that corner nicely. Alright, if you enjoyed this lesson and want more like this coming every single day, make sure to subscribe to this channel. We have several other lessons on adaptive components and curtain panel pattern based, so make sure to check out our playlist to help you further master these very exciting tools. For now, get the Dynamo script from the description, practice creating those nice panels, and I'll see you in the next lesson.